A boat is sailing with constant velocity at time t hours afternoon. The position vector of the boat is r kilometers. When t is 0, r vector is given kilometers, and when t is 3, r is given kilometers. Question: calculate the speed of the boat. So this situation looks like this. There is some origin somewhere and a position vector at t is 0, and at t3 there is another position vector, and if we connect end points, this vector is directly difference of two vectors, and it's r at 3 minus vector minus r at 0 vector, and it's displacement vector, and displacement divided by time gives us this vector gives us the required velocity vector. So velocity vector is just r at 3 minus r at 0 and divided by time, which is 3 hours. And we can write this like this, so it's 1/3 like a coefficient, and vectors I write as a column instead of ij, so it becomes 4, -2, 4, -2 minus minus at 0 it's what, -5 and 10, and 1/3 9, -12, and 9 divided by 3 is 3, and -4, and it's the required velocity vector. B. Find the direction in which the boat is moving, given the answer as bearing. So direction, to get the direction of motion, we should consider this velocity vector, because this velocity vector gives us the direction of motion, and it looks like this. This vector 3, -4, it's what? This vector looks like 3 squares to the right and 4 squares downwards. So this velocity vector is in such direction, so that 3 is here and 4 is here. And if we can find this acute angle theta from what? From tangent. So tangent is opposite over adjacent, 4/3. So theta, it's inverse tangent of 4/3. And it's 53.1 degrees, and we need this direction to be given as a bearing angle. To get bearing, we should at the starting point we should draw north upwards, and in clockwise direction this angle, it's a required bearing angle, and you can see that we need just add 90 degrees. So the required bearing is 90 plus 53.1, and it's 133 degrees. Bearing, we give bearing as 3 whole numbers. If there are only 2 digits, you should write like 0.43 or something like that, and decimals are not required. So bearing is 143 degrees. The next. Determine expression for r in terms of t. So position vector of this boat. It's what? Position vector of the initial point or the starting point. It's when t is 0, it's -5, 10 plus time multiplied by the velocity vector, which is what? 3, -4. The next. A beacon is located at the point with position vector 10 and negative 10 kilometers. When t is capital T, the boat is at distance of 15 kilometers from the beacon. Question D determines the two possible values of t. So this situation looks like this, that position vector of the boat at any moment of time, and there is a position vector of the beacon. Let it be RB, and it is given that at some moment of time this distance is 15 kilometers, and our position vector of a beacon is 10, negative 10, and again, if we consider this distance with respect to vectors, it's what is directly the difference between two vectors. So this distance, it's RB vector minus R vector. So it becomes RB minus R is what? Negative 5 plus 3t. It's it's RB, so it's 10, negative 10 minus R, negative 5 plus 3t, so it's minus, let's write like this, minus negative 5 plus 3t, and minus 10 minus 4t, and it is equal to, so it's 10 plus 5, it's 15 minus 3t, and negative 10 minus 10 is negative 20 plus 4t, and magnitude of this vector, in general it can be considered R minus RB, doesn't matter, because if we consider distance, it's magnitude of this vector, and this magnitude should be 15. And what is the magnitude of a vector? And it's square root of the sum of squares, so it becomes square root 15 minus 3t squared plus negative 20 plus 4t squared is 15, and if we square both sides we get, I can rewrite like as 3t minus 15. It doesn't matter because 5 squared 25 and negative 5 squared is also 25, so 3t minus 15 squared plus 4t minus 20 squared is 15 squared, it's 225, and it becomes what, 9t squared minus 2 times 3 times 15, so it's what, 30 times 3, it's 90t plus 225 plus 16t squared minus what, 160 plus t plus 400 is equal to 225, and we can see that we can cancel it, and we get a quadratic, so 25t squared minus 250t plus 400 is equal to 0, and we can see that we can divide each term by 25 to get t squared minus 10t plus 16. We can use discriminant, or it can be easily factorized, and it becomes t minus 2, t minus 8, and is 0. Hence t1 is 2, and another solution is 8 hours. And that's all for this question.